Okay, so the next problem is we are solving lead code is maximum number of vowels in substring of a given length. Okay, and as we know, these are the vowels A, I, O, U. Okay, and we are given the string S, and we are given the substring length K. Okay, so K is equal to 3, meaning like will be different substrings, but of the same length K. Okay, A B C is one substring, B C I, C I. Okay, so what is our task is in all the substrings, right? We'll have to find out the maximum number of vowels. Okay, maximum number of vowels we'll have to find. Okay, let's say that in ABC, how many vowels we have? Only one. So okay, in BCI is also only one. I, right? Yeah, CII we have got two vowels. Okay, and at some point in time we got this as a substring I, and we know that I all three are vowels, and this is the maximum one that is being shown here. Like even though if we move the sliding window, or if you move the go for an next substring also, we might be not getting it, or this will be the maximum one. Okay, so now how to approach this? Okay, so now what we'll do is what one thing we can do is we will, instead of doing the calculation again and again, right? So let's say that I pick for ABC. Okay, so for what I will have to do, I will have to check if A is in AIOU, B, and similarly C, right? I'll have to do these things, but that will simply increase the time complexity, right? So what we can do is simply, for the first time, for the given window size, for a given substring size, we will do the calculation. Okay, for ABC we'll do the calculation and keep it aside, and next time when we start from this, right, BCI, let's not go through each and every one. B, if it is an oval, C it is an oval, and I it is non oval. Instead of doing that, what we can do is, previously we know that what is the oval count, right? We'll have to check it here. We already did a calculation for BC here, correct? ABC here, ABC is here, and we already did a calculation for A. Okay, yeah, so we already did a calculation for ABC, right? When we are ABC, we already know that if it is a okay, sorry for the disturbance. So let's say that this is the window. Okay, like we already did a calculation for this, and so then our next window will be this one, correct? And among these, we know how many vowels were already there, correct? And when I move to this, what I will have to do, I simply have to calculate the vowels for this one, if it is a vowel or not. If it is a vowel, I will increment the count of it, because among ABC, right, BC is already evaluated. We'll come to A. Okay, so in this window, this is we already have calculated the how many vowels we have. Okay, and in the next window this will be there, BCI, correct? We will check if I is an vowel or not. If yes, we'll increment the count, whatever the count we have, right? Will previous count we had, we'll increment the count. Okay, and also we should be ignoring A, because A was an vowel, but A is not present in the current current window, correct? We'll have to subtract that value from the current value. Okay, so that's it actually. Like for what we are trying to do here is, this will be the window. Initially this will be the window, and in the next window the I got added, A got removed, correct? So what we'll do is, we'll keep a track of the current vowel counts. In the first window we have one vowel count, so the current count will be 1. Okay, and in the next window what we'll do is, whatever the character that came in new, right, we'll check if that is an vowel. If it is there, we'll increment the current count, and also in the same time we'll check the last character that was there in the previous window. Okay, if that is an oval, we'll have to subtract it, because when doing this calculation we add that we have that value here, right? So, but we don't want that value here, so we'll just subtract it. So that what we are trying to do here is, we don't want to evaluate again B and C. Okay, like here it looks simple, because there are only three characters, but if it is K is equal to big one, right? Like doing the same calculation for each window, like for each character change, will introduce the time complexity. So that's why we'll go about this way. Okay, let me show the code actually here. So first we'll do the evaluation for the first window. Okay, 0 to K, and we found some current, how many vowels, right? That will set it as a maximum one, like that is the maximum count we are getting. If it is 0, it will be 0. Okay, and now the window starts from 1 to 3. Like let's say that from the here to here. Okay, like the fourth index. Okay, so we from here we'll do the same thing, like when we are doing calculation, right? Check if the previous windows for last character, right, windows last character was an oval. If it is an oval, decrement it. And also, like in the new window, the new character, is it an oval? If it is there, increment it. And at the finally we'll check the maximum count for the current, if it is the current one as having the maximum one, or the previous one. That's it. Similarly, we'll just slide our window. Yeah, thank you.